right, so what if we want to take the derivative of something like 2 to the x power? Or in other words, what if we want to take the derivative of an exponential function whose base is not e? So that's what we're going to focus on today. Now, it says here, how could you prove the derivative of y equals x to the n? Now, this is like way long ago. We know how to do this. Well, in advance, understanding that n is a constant, I'm just going to make myself a note here just so that we're all on the same page. Well, we know that we would use our power rule, and it would be n times x to the n minus 1, right? We've done that before. We know that. But there's another way that we can prove this, and I'm just showing this because it's related to how we will find the derivatives of exponential functions of a different base. So here's my other way to prove. We've already shown this once before. Let's say we're going to take the natural log of both sides, right? What I do to one side, I can do to the other. That's a totally valid step right there. I did the same thing to both sides. Now, before I go and start taking derivatives, well, don't forget we have this power rule, which means that I can multiply this exponent in front. Is that bringing you back to good times? That's what I thought. All right, derivative time. All right, well, we just talked about how the derivative of natural log of y, well, if I were to use implicit differentiation, that's y prime over y. And here, note that I don't need to use the product rule because n is just a constant. So it's just n times whatever the derivative of natural log of x is, which is 1 over x. Great. Well, now, notice that we have this y. Whoa, that scared the bejeebers out of me. Anyway, notice that we have this y down here, and we want to just solve for y prime. So, let me get some more space. Let's multiply both sides by y. And remember, y is just x to the n. For right now, I'll just leave it as y, just so I don't confuse you. I just rewrote those. Remember that I can replace y with x to the n. And I'm actually going to rewrite this as x to the negative first. I hope that's okay with y'all. And now don't forget, last thing that I can do here is since I have x to the n times x to the negative first, that's like adding their exponents, which gives me n times x to the n minus 1. Bada bang, bada bang. Another way to prove. Yippee. Okay, so how on earth is this relevant to what we're doing now? Well, let me show you. All right, now we want to know what's the derivative of a to the x. So a being some base. We know that it's greater than 0, right? We want to find its derivative. So let's do this in a similar way. I'm going to rewrite this as y equals a to the x. Let's do what we did before, peeps. We're going to take the natural log of both sides. I'm just showing this because then we get to make a really cool conclusion. Okay, so we did that. Before I start taking derivatives, let's use our power rule and bring that x in front. So x times natural log of a. Now don't forget, a is a constant, so natural log of a is just some number. Probably a weird one too. Okay. Derivative time, take the natural log of y. Its derivative is y prime over y. If you're not sure where this is coming from, then you probably need to look back at our previous notes. Here, again, I don't need to use our product rule. It's just the natural log of a. And you're wondering, why? Well, because this is x to the first power times a constant, so it's just the constant. All right, then we're almost done here. I can multiply y to both sides, but we can replace y with what y is equal to, which is a to the x. And ta-da! We now know that the derivative of a to the x is a to the x times the natural log of a. Not too bad. So for example, I'm just going to make one up real quick. If I wanted to know what's the derivative of 4 to the x power, it would be itself, which kind of reminds me of the derivative of e to the x, times the natural log of its base. And if you think about how we did this with e to the x, well, remember that that was just itself times the natural log of its base. But what is the natural log of e? Y'all are so smart. Just 1. Also, if we do have an exponent that is something other than x, so let's say it's some kind of like x squared plus 1, don't forget we do need to multiply by the derivative of that. So chain rule. Let's put it into action here. So find the derivative of f of x. Okay, well, we now know this awesome rule. F prime of x. So it's going to be itself times the natural log of its base times the derivative of its exponent, which is just 3. Sweet. If you were wondering how that relates to before, well, this is a to the u times the natural log of u. Oh, wait, no, natural log of a in this case. And then this is du dx. You don't need to know that, but just something cool to know. All right, next one. Find y prime given that y is quantity natural log of x squared. Okay, so this one's going to be a little interesting. Okay, so now notice that this is not a standard log or exponential function. You're like, well, I thought we were just about to do that. We are, but we're going to make it a little harder because, you know, this is math analysis honors. Okay, so we're going to do it similar to how we did before, and we're just going to take the natural log of both sides. And this is pre-derivative. Yeah, I know, this is going to look weird. Just trust me, okay? All right, same as before. Let's bring that exponent in front. I know you're getting nervous. Just stay calm. Trust me here. I got you. Okay. Now, we can totally do this. We can take its derivative because we're looking for y prime. Now, I know that the natural log of y, its derivative is y prime over y. Over here, do we need to use the product rule? You're right. Yeah, we do. Good call. So, let's take a look. It's going to be the first times the derivative of the second. Well, it's going to be 1 over natural log of x times the derivative of the inside, which is 1 over x. All right, so the first times the second plus the second times the root of the first, which is just 1. Wonderful. Okay, well, conveniently, x and 1 over x will multiply to equal 1. I'm going to multiply y to both sides, and I'm just going to put some brackets around it just because, you know, I don't want things to get ugly. And you're thinking, it's already ugly. Sometimes I just have to sit back and laugh at myself because I'm making jokes to nobody. I'm sitting in this room all alone making this video. Okay, stop talking to you. All right, last step is to replace y with what y is. And if you look at the original problem, we know that y is natural log of x quantity squared. So natural log of x quantity squared times all this jazz. Now you're wondering, oh, do I have to simplify this? And I'm thinking, are you crazy? Who wants to do that? I have no idea what's going on with these accents today, so don't ask. Awesome. All right, next one. Find the derivative of the natural log of x to the natural log of x power. It might help you to show, you know, y equals natural log of x to the natural log of x power. So, I am going to challenge you guys. Yes, my job is to challenge you. I'm going to challenge you guys to find this derivative. So basically you're finding y prime here. As a little hint, you will want to take the natural log of both sides. If it feels weird, you're doing it right. So go ahead, put me on pause, and then we'll check our answers. Okay, peeps. So I did give you the hint to take the natural log of both sides. You can see that I did that right here in blue. Before I started taking the derivative, I used my power rule for logs, and I brought that natural log of x in front. Notice when I take its derivative, I will have to use the, the product rule. So I did that. I got y prime over y equals the first times the root of the second plus the second times the root of the first. From there, I mean, nothing crazy. These natural log of x canceled out, so I was left with 1 over x, and this is natural log of x all over x times y, but y was natural log of x to the natural log of x times the quantity 1 over x plus natural log of x all over x. All right, so in conclusion, the derivatives of exponential functions of other bases are derived using implicit differentiation. That is true. We saw that, and it was cool. Good job.